Hello guys, welcome again to my channel. Here comes a nice challenge which read 45 to the power of m minus 20 to the power of m divided by 5 to the power of m equals to 65. And what then is the possible value for m? So we are looking for the value of m in this challenge. So let's see how we can solve for this. So please, if you are new here, kindly subscribe to this channel. And by the time you subscribe, please don't forget to turn on the notification button so that you get notified whenever I drop videos on mathematics. So let's see how we can solve this. We can say solution. Okay. Then write the question, which is 45 all to the power of m minus 20 all to the power of m divided by 5 to the power of m is equals to 65. Okay, haven't done this. What are we simply going to do? We are having a numerator and we are having a denominator 5 to the power of m. Okay, having this, we can break 45 down and we can break 20 down. So if we should break 45 down, our 45 is equals to 9 times 5, and our 20 is equals to 4 times 5. Okay, so in place of 45 we should put 9 times 5, and in place of 20 we'll put 4 times 5. So if we should simplify this further, we have this to be 9 times 5 all to the power of m minus 4 times 5 all to the power of m. Okay, divide by 5 to the power of m is equals to our 65. Okay, haven't done this. A basic principle from indices, which is a times b all to the power of c is equals to a to the power of c times b to the power of c. So if we should put this principle here, we simply have this to be 9 to the power of m times 5 to the power of m minus, let us put a bracket here to demarcate it, minus 4 to the power of m times 5 to the power of m, close bracket, or divide by 5 to the power of m, okay, equals to 65. Okay, haven't done this, we can see that 5 is not common between them. So if we should factor out, we have this to be 5 to the power of m, open bracket, 9 to the power of m, minus 4 to the power of m, close the bracket, over 5 to the power of m, okay, equals to 65. Okay, haven't done this. You can see that we are having 5 to the power of m at the numerator, and we're having 5 to the power of m at what? The denominator. So this and this we go. This and this we go. So we are left with 9 to the power of m minus 4 to the power of m is equals to 65. So this is what we are now having. Still yet, we are still having m. So let's move further to solve for m. Okay, since we're now having 9 to the power of m minus 4 to the power of m equals to 65, so what are we simply going to do? Okay, having this, the first thing we can do is to rewrite this again. We can rewrite this again by saying 9 to the power of m, open bracket, close bracket, to the power of 2 over 2, which remains the same, minus 4 to the power of m, open bracket, close bracket, to the power of 2 over 2, which also remains the same, equals to 65. Because if these two should cancel these two, and these two should cancel these two, we are returning back to this. Okay, haven't done this. What are we simply going to do? Okay, now we are not having this. So the next thing we can do is to rewrite 9. 9 can be written as 3 to the power of 2, okay? And 4 is also equals to 2 to the power of 2, okay? So having this, so in the place of 9, we can put 3 to the power of 2, and in place of 4, we can put 2 to the power of 2, okay? So we can write this to be 3 to the power of 2 times m or to the power of 2 over 2, okay, minus 2 to the power of 2 times m, or to the power of 2 over 2 is equals to 65. Okay? Haven't done this. Recall from your basic principle of indices, which say a to the power of b or to the power of c is also equals to a to the power of b, c. So if we should put this principle in all this, we have this to be 3 to the power of 4m over 2 minus 2 to the power of 4m over 2 equals to 65. Okay? Okay, some may say let us easily cancel that. Let's easily cancel that. We can do that, but it's going to make this question look complicated to solve. We can still do that, rather. We can do that to make it, we can still solve it like that. But let me show you this other one. Okay, instead of us doing this, we can say, okay, let's bring this out. So we can say this to be, let's bring out this 4, which replies to be 3 to the power of m over 2 or to the power of 4. Okay, minus 2 to the power of m over 2 or to the power of what? Of 4 is equals to 65. Okay? Okay? So what are we simply going to do? We can say, okay, let's p equals to 3 to the power of m over 2 and q equals to 2 to the power of m over 2. So if we should write this again, we are having this to be p to the power of 4 minus q to the power of 4 is equals to 65. Okay? P to the power of 4 can be written as p squared open bracket all to the power of 2. So we can say this to be p squared all to the power of 2 minus q squared all to the power of 2 equals to 65. Okay, haven't done this. We are now going to say let x equals to p squared and let y equals to q squared. So what are we now doing again? We are saying let x equals to p squared and let y equals to q squared. So wherever we see p squared, we are putting x, and wherever we see q squared, we are putting y. So let's substitute this value and solve further. Okay, since we're not having this, let's substitute wherever we see p squared, let's put x, and wherever we see q squared, let's put y and solve further. So if we should do that, we are now having x squared minus y squared is equals to 65. Okay? We're now having x squared minus y squared is equals to 65. So since we've done this, we can write x squared minus y squared is also equals to x plus y times x minus y. So if we put this principle here, we're having this to be x plus y times x minus y is equals to 65. Okay? And we can rewrite 65. 65 is equals to 13 times 5. So if we should do that, we are having open bracket x plus y times x minus y is equals to 13 times 5. Okay? So we are now having this. Always note that x plus y is greater than x minus y. So x plus y is going to take the bigger value, x minus y is going to take the smaller value. So if we should do that, we are having x plus y is equals to 13. We can call this one equation 1. X minus y is equals to 5. Then we can call this one equation 2. So we've gotten our equation 1 and equation 2. We can solve this using the simultaneous equation using the elimination method. So if we should use the elimination method, so this plus this is going to give us 2x plus y minus y is going to give us 0 is equals to 13 plus 5 is going to give us 18. Okay? So if we should divide both sides by 2, our x becomes 9. Then if we should move on to equation 1 and substitute the value of x there, so we could say let's substitute 9 into equation 1, and this is our equation 1. So wherever I see equation 1, wherever I see our x is equals to what? Is equals to 9. So we are saying x plus y is equals to 13. Okay? Haven't done this. So what are we simply going to do? Recall we said x is equals to 9, right? So we can say 9 plus y is equals to 13. Okay? Therefore, my y becomes equals to what? Equals to 4. Oh, since we've gotten the value for x and for y, recall our x is equals to 9 and our y is equals to 4. And we said our x is equals to p squared, okay? Then our y is equals to q squared. So let's solve further. So we know that our x is equals to 9 and our y is equals to 4. So we can say 9 rather p squared is equals to, cancelling of this, p squared is equals to 9 and q squared is equals to 4. So therefore my p is equals to 3 and my q is equals to 2. Okay? So let's solve further. Okay, so we are now having p is equals to 3 and q is equals to 2. Also recall that we said p is equals to 3 to the power of m over 2, and we said q is equals to 2 to the power of m over 2. Okay? So we are now having the value for p. So we can say 3 is equals to 3 to the power of m over 2, and 2 is also equals to 2 to the power of m over 2. Okay? So this and this will cancel. So what are we now having? We are now having 1 is equals to m over 2. So this and this will cancel. We are now also having 1 is equals to m over 2. So if we should cross multiply, therefore our m is equals to 2. Our m is equals to 2. We can see that now the value of m is equals to 2. So let's substitute m into our question to see what is going to give us 65. So let's do that. Recall we said the question is 45 to the power of m minus 20 to the power of m over 5 to the power of m is equals to 65. Okay? So since we are having this, we can say 45 to the power of 2 minus 20 to the power of 2 is equals to 65 over 5 to the power of 2. Okay? Having this 45 to the power of 2, 45 to the power of 2 is going to give us 2025. So 2025 minus 400 over 25. Okay? Over 25 equals to 65. So if we should subtract this value from this and divide by this, is going to give us 65. So let's do that. So if we should subtract 400 from 2025, we are going to have 1625 over 25, and now is equals to 65. Okay? 1625 is equals to 65 times 25. So we can write this to be 65 times 25 over 25 is equals to known 65. So this and this will go. So we're now having 65 is equals to 65. So the value of m in this challenge is correct. Recall we said our m is equals to 2. So if you find this video useful and interesting, please click on the subscription button if you have not done that, and also turn on the notification bell so that you get notified whenever I drop on some videos on mathematics. Please, if you have not hit on the thumbs up button, please do well to do that. Bye for now. God bless you. Jesus loves you, and see you in my subsequent video. Bye bye.